Good morning, everybody, if you're in a relatively local time zone, or good day if you're somewhere else. Today we're going to talk about the PostNL use case and how they scale to 100 million messages per day. But first, these are your presenters today. My name is Jeroen van Disseldorp. I'll be doing this session together with Guy Hagemans and Mendel Leinenburg, and they will introduce themselves as they start their own part of the presentation. Today we're going to talk about three different subjects. First of all, a bit of an introduction into data streaming, particularly how that relates to APIs and batch processing. Then we'll dive more in detail into the PostNL case with a demo that illustrates how PostNL has solved their streaming issues. My name is Jeroen van Disseldorp. I'm founder and CEO of Axual. And I will do the first section talking about data streaming. So if you look at the way that companies do data integration nowadays, there's three basic patterns in order to do data logistics, so to how to push data around between different applications. And I'm comparing them in this slide to parts of the human body in order to make this a bit of a CEO boardroom level understandable. So let's look at how data integration can take place. First of all, we have batch processing, which is really comparable to your digestive system, because typically you eat 3 times a day. You do that at regular intervals, regular times. When it's 3:30 in the afternoon, you tend to wait until 5:30 or 6 o'clock when you're at home with your family at the dinner table. So there's something of a time aspect to how you eat and how you schedule your daily routines. And that's the same thing with batch processing. When you push data around in terms of files or large data sets, usually there's like an arrangement that data comes in at a certain moment of the day or a certain time of the hour. And you expect that as a receiver. So you'll be probably scheduling your processing time after a certain period and making sure that the probably lengthy but predictable processing is scheduled right after you receive those files or data sets. This is typically done just a few times a day and not really comparable to how you do APIs. Because if you do APIs, or well, we used to call that service-oriented architecture, RPC, or web services, or it has many different names, but it's typically request and reply. And that's really comparable to how your brains tell your muscles to contract or relax. Your muscles would be the servers in this case, the lots of individual commands being transmitted between the brain and every individual muscles. So there's typically 2 involved parties in a request-reply pattern, and your brains have a specific intent because they want to get something done. They want you to start moving, or they want you to open your eyes. Anything that it wants to get done, it has to send individual commands to your muscles to start moving. That is still a completely different pattern from how we do event streaming nowadays, because event streaming is more comparable to your nervous system. So think of your skin or your taste buds or your eyes taking up all kinds of signals from the outside world, and they put that as individual signals, notifications on your nervous system to be picked up on by different parts of the brain. And in your brain, you have contextual processing going on. So, well, there's some sort of an anomaly detection. You see whether you can use a certain signal or not. Does it fall outside of the expected boundaries or not? And if it does, you'll probably handle it differently than when it's just something that you would expect to be happening at that point in time. That just as a simple example, you're mostly sitting down probably now, but if I tell you that you're sitting down, you all of a sudden start to feel the pressure that you exert on your chair, whereas 2 seconds ago you weren't even aware of that. So context really does affect the processing. Typically, it's all kinds of independent systems that do this processing. So if a system joins or decides to not join anymore, the rest of the whole system does continue as it did before. So How does this work with well, data orientation or command orientation? Typically, the middle one here is command oriented. So when I send somebody an API call, I typically ask or well tell the server to do something for me, whereas the first one and the last one is more data oriented. Here's your data, and you decide what you want to do with that. Typically, all three are part of modern data architectures. We'll be focusing mostly on the latter. And of course, it's been the major trend of the past years to implement something with event-driven architecture. But sometimes I also get the question, what if we were to move everything on data warehouse to event streaming? Is that possible? Well, the analogy here really helps, because if you lose one of these systems, you basically die. And that's what we also see in organizations. Well, if you have to do formal reporting to regulators or to somebody else, you'll probably mostly use data warehouses or a better type of processing. If you want to get something done, it's more APIs. And if you want to notify something to the outside world, or basically broadcast something, event streaming is more appropriate. So let's look at different kinds of use cases for data streaming, and I'll quickly go over this, but just to give you an indication of where data streaming is being used nowadays. First area is everything that has to do with customer or customer service. Customers give you signals all throughout the day. They visit your websites, they interact with your apps, they have all kinds of products that they're interested in, and every signal that you can get from the customer helps you to build up the 360 customer view. So typically, systems would notify about customer signals, and a customer profiling application could build up that 360 customer view. Also think of real-time alerting, smart assistants, anything that you can use the customer signals for in order to help them better at a later point in time is definitely an area where streaming is really successful. Another one is around ecosystem integration. So where different parties decide to work together around the common business process. Think of, harbors like Rotterdam Harbor or airports, where you have a lot of different companies, logistics companies, transportation companies, all kinds of coordination companies working around a common business process. But where we have these 4 airlines today, tomorrow 2 of them are bankrupt and 3 new ones can arise. It would be really easy for them to pick up on the business process by connecting to the central event streaming platform and participating in all of the coordination that goes on there. Also think of non-competitive sectors like municipalities. If you move between different cities, they probably have to coordinate your address and your data to be moved from one municipality to another. And the same thing is also internally in organizations, where backend systems are integrating with front-end systems through event streaming platforms. A third area where you see a lot of data streaming going on is around speeding up processes, going from batch processing to continuous batches of one, which typically describes streaming. Think of real-time dashboards. So you don't wait until 12 o'clock to get new data in to fill your new dashboard for the next hour, but you want to get all kinds of different signals throughout the hour to be able to update your real-time dashboards with. Same thing for fraud anomaly detection, continuous data exchange with your business partners. That's all stuff that used to happen in batch, but now business just simply requires that it's a more continuous flow of information. And of course, last but not least, sensor data processing, which is also relating a little bit to the PostNL use case coming up. But think of smart meters, smart grids, railways, train stations, everything where you have a lot of sensor information collected that can be transmitted through a streaming platform to a central place where it's being processed and put into dashboards, or it builds up a common operational picture, or in general, it gives you better situational awareness. All right, so that is all done on a streaming platform. So let's look at what a streaming platform typically looks like. Here you see a typical platform in the heart of an organization with all different departments of a typical organization around that. And the platform in this case provides or intends to provide a marketplace where you can exchange all of your business events. And of course, a business event is something that you have to define yourself. For some organizations in the financial sector, loan status changes or financial transactions could be typical business events. In the PostNL case, as you'll see, a parcel being scanned by a mailman is a typical business event that is put on the platform. And after that, you have three types of interactions. You have producers of these events, so applications that share data in business meaningful terminology. So you don't talk about event type 3 because the other party in your organization has to understand what event type 3 means. You typically write out those events. So a parcel status update would be more of a better description. So anybody in the organization can understand what this event really means. Consumers, they subscribe to these events and they handle the messages as they come in. And the category that does both, so that reads from one or more event streams and writes out to one or more other event streams, that's what you call streaming applications. And those typically do calculations, aggregations, joins. And this is also the category that Guy and Mendolt will dive more in depth into in a moment. So why is this model so important to have a central streaming platform? Well, typically because all organizations that share data by default, they tend to outperform their peers in the market that don't. So data sharing has become a crucial business capability that companies are advised to adopt because simply if you lock up data in stovepipes, you will definitely not perform as high as your peers in the market that do so. So that's been proven by research time and time again. So this model of having that central event streaming platform really aligns with business goals. But then, of course, you do have to implement such a platform. And that can be a bit challenging because nowadays the front ends of organizations are mostly oriented in DevOps kinds of teams. So every team is responsible for their own IT products, their own business products, their own markets, their own customers, their own market segments. But somehow you have to integrate them onto a common backend, being the event platform in this case. So we've experienced throughout the time that there's typically three ways in which you can implement such a platform. The first one is to open up everything. And this is initially how LinkedIn got going with Apache Kafka. So they owned all the data within LinkedIn. There was no security built in. It was just a means of sharing data between different applications. No security, no certificates, no encryption. So basically, if you knew where to find Kafka on the network, you could participate in any kind of data exchange. But of course, with modern data regulations, privacy regulations, this is completely not an option anymore. You have to shield your data, encrypt the data, and make sure it doesn't fall into the wrong hands. The other way to implement a streaming platform to work for multiple DevOps teams is to authorize a central Kafka team. This is what we also used to do at Axual for several customers. We were that team, being able to configure the streaming platform and making sure that everybody can only act within certain guardrails. And then what you typically get is a situation in which you do the functional maintenance as a Kafka team. So you get questions like, can you deploy this topic for us? Can you change the schema on this particular topic? Did my message arrive? Everything that, well, development teams would be asking for because they don't have visibility, they don't have control over the configuration. That is what you can then expect. Of course, that's not the way that we wanted to go because this gives the situation that the central Kafka team really becomes a bottleneck in your organization. So also a no-go. So the third way we decided to implement is to really implement the whole streaming platform as a multi-tenant platform. And in order to do that, we found out over time that you need three crucial capabilities: data governance, making sure that everybody in the organization has certain rights and has the ability to do something. Well, if you have those rights, then you need to be able to exercise them, and that is what self-service is meant for. So self-service is a way where users can log in and they can configure and define their own piece of the pie of the whole streaming platform. And last but not least, if that works for everybody, of course, they should be able to rely on the security, so no data can fall into the wrong hands. And also, I won't be able to manipulate the topic or the application of my neighboring team. So that is something that needs to be guaranteed by the platform. All right, so with that theory in the back of our minds, I would like to hand it off to Guy to talk more about the PostNL use case. Guy, go ahead.
Thank you, Jeroen. Let me share my screen. And then, I'm Guy Haagmans. I'm a cloud integration consultant for Appythings, and I'm really excited to share some of the details on the PostNL case. So as an introduction to the business case for PostNL, the challenge for PostNL was to phase out an old bespoke IT solution that was responsible for information surrounding parcels, and secondly, to phase out all the legacy applications that, for example, are using costly SFTP. Finally, also to provide a future-proof integrations platform in order to be more flexible in how we can deliver to PostNL's B2B and also to the B2C customers. So self-service here is very important because of the number of customers that are using PostNL's integrations. But also to increase the adoption of the streaming platform internally within the organization itself. So to tackle this, we turned to Actual Cloud, which is a powerful platform that offers robust streaming capabilities for handling high volume, but also business critical use cases. We used KSML to perform the many event processing that needed to take place to transform the parcel status changes into outgoing notifications. And our approach included also setting up configuration topics that support business logic. All of this is supported by a series of microservices and that are low code and easy to maintain. I think the journey that PostNL took and how we got here is interesting and good as a starting point to provide to you all. So PostNL started more than a decade ago with their APIs and API management. It was and is a successful project, and the customers of PostNL, the big ones, but also the many small web shops were very, very happily using the APIs. The success, however, also has a downside because high API traffic also means higher cost. And as mentioned before, one important example is the tracking of parcels. So there was an API available for this. This was a GET API, and especially the larger customers of PostNL, which have tens of thousands of parcels in transit, were using this API to get the status like every minute or so for every parcel. And this is inefficient because the status of a parcel sometimes does not change for an hour or even longer. But once the status is changed, you do want to give a timely update to your consumer. So it's much more efficient to push these changes instead of doing a GET request, which we're here referring as pulling the status. So a few years ago, we set up a proof of concept using AWS serverless components and custom code to push these parcel status changes to the bigger customers of PostNL. This worked really well. However, to expand this capability in the organization and to mature it further, the decision was made to leverage mature technology such as Actual on Kafka. I would like to shortly stop by this slide and explain why we chose the solutions that we currently have for PostNL. So this slide is part of the Appythings integration architecture framework. In the integration world, we have different ways of sending data across. We acknowledge the dialogue, event, and file-based integrations. What is important is that there's no good or bad technology, but you have to find the right technology for the right use case. Also important is that you have to size these technologies in the right way in order to be cost effective. And for PostNL, there are thousands of small web shops that want to know where their parcels are in the chain. So for these small web shops, a dialogue-based integration is an optimal solution because it is easy to set up. It requires little to no setup from their side. because it's just a simple HTTP GET request. However, the larger customers of PostNL, for example, bol.com, which is like the Amazon of the Netherlands, their volume of parcels and thus also the events is so large that an event-based integration is optimal. So to provide a bit of context before we go into more detail, one of the things we're doing at the moment with the event platform is to transform what we call observations to relevant information. The main input for this is PostNL's brain, being EDS on the left. In EDS, it receives the observations from, for example, delivery van, delivery people, and from warehouses where the packages the parcels are delivered to and shipped from. These observations on their own do not hold much value, but based on rules that are, for example, set by e-commerce, for example, by defining what event updates are allowed to be sent out to PostNL's customers, and by getting the preferences that are set online by consumers, we filter and branch the events and determine the right channel to send the information to. So businesses which are large customers of PostNL might want to receive these events in bulk via a file transfer, a bucket, or maybe in the future even a webhook. But certain consumers might want to have, most of the time want to have their updates on their mobile phone instead of an email or vice versa. So by processing these events in the right way, with the right logic, we create value and we process this data into relevant information. So along the way, during this journey and given this context, a few challenges, of course, emerged. The first challenge we saw was governance. There are multiple parties that are sending events and configurations to our platform. In the future, we expect many more systems to do this and also to consume the data that's being produced. Data governance is key here in making sure that it is clear what data you're working with and what you can expect. But yeah, all these topics will be in more detail later in the presentation. The realization of streaming apps could also be a challenge because you might not have Java developers available, and Java is typically the language you are writing streaming apps in. Security is the third and the last topic. When dealing with customer data, which is often the case at PostNL because we're dealing with addresses, for example, the data is best secured using MTLS. But how do you manage those certificates? How do you manage access to the topics to which the data is streamed? Yeah. So to start with governance. So in this scenario where you have a streaming platform where different departments can produce and consume data to and on, one key aspect of governance is who owns what data on the platform. Because after running the project for a couple of years, you might have hundreds of streams, and there's also many consumers and producers on these topics. And it is a lot of responsibility to keep all of this data running well, because there's just so much data flowing through your platform. So one rule that we found is working really well is whoever produces the data, so in other words, the party or team that is sending the data to the topic, to the platform, they are also the owner and thus responsible for that data. This means that when you have several other teams consuming the data to this topic, there might be questions on what exactly some of the data means. So why was there a hiccup in the data being produced? Why was there a change in the data from a certain time? And of course, as an integration team member, you're happy to help with all of these questions, but it really helps in making sure that the party that produces the data is aware that they have this responsibility, that they are the owner. You'll see it later in the demo, but with Axual, it's very easy to assign a team as the owner of a topic. It's easy to manage this team. And in all of the projects that I've seen, this team is also the owner of the topic and thus the data. Next is the schema lifecycle. So we really recommend using schemas for all of your events, but it's important on how exactly you use schemas and how you review them, because using a schema for your event is a bit like having a database schema, where in the database schema it's also defined in what table you have what fields and with what types. It takes a bit of effort to create these schemas, but on the other hand, with most programming languages. Using the schema, you can generate code which based on the schema, which helps in getting back some of the time that you invested. Schemas actually helped a lot for PostNL because when, for example, using an Avro schema, when producing or consuming messages, a message that does not adhere to the schema gets automatically rejected, meaning the code that you're using to consume or produce a message to a topic will throw an error. For a developer, this can be a bit annoying, but yeah, it really helps in making sure that the data adheres to the contract, the schema, and you're not dealing with garbage data, which can create problems further down the chain. So a linked important topic to this is schema reviews, which also touches governance. What we recommend doing is setting up a repository with all the schemas that are currently that you currently have in production. And when the data owner wants to publish a change to the schema, they make the change in a branch, and then when they push the change, a CI/CD pipeline automatically validates the schema for validity and compatibility. There is free tooling available for this from Stoplight. So yeah, finally, when having a central repository with all of your schemas, it's great for other teams who want to have examples, for example, and makes it easy to review schemas. So talking about events and schemas and their design, I'd like to discuss some best practices that are related, which are the following. So it's a good idea to keep an eye out for YOLO events. This means that when any business starts with an event, what happens sometimes is they keep adding attributes, maybe have different styles for the event and how it should look as they go along with the requirements as they come. So this is not a good approach because the message could become inconsistent, difficult to read, hard to process. So it's really important to try to find a good balance for an event or actually between an event that has too much information and one event that is too sparse. Because an event that has too much information, we also call it a God event. It contains too much detail about, for example, an order. So for example, it contains the information on the order, how it is fulfilled, what support tickets are open for that order, and much more. An event that is too sparse can also create issues when it is sent to the parties that are consuming this event, because those parties then might want to know more about the event and will start calling, for example, this order API and check on what the details are. So something we were working with at PostNL is what PostNL calls the P360 or the partial 360 degrees event. This model is really nice because it creates consistency and clarity around the organization on how parcel information should be communicated. It basically defines the meta model of a shipment. It also means that the model contains a lot of information. So one thing we did for a stream processing application that helped really in reducing the cost through, for example, reducing processing power and disk storage after receiving the event. We stripped down, so after receiving the event, we stripped down the information that is required for the stream processing application. And this is a simple steps, but it also makes all the steps that process the message further down the chain much lighter. And that brings us to the next topic, which is streaming apps. Before we started the project at PostNL, PostNL had no experience with event streaming, with an event streaming application on Kafka. So during a workshop together with Axual, PostNL, and Appythings, Axual showed us the alerting solution of the Rabobank in English. And yeah, together with architects from PostNL, we created a high-level design. In design, it was clear what the input and the output would be for every process and business function. And then these would be translated to input and output topics. But the logic in between the topics, that's handled by an event processor. And For PostNL, we handled this mostly by using KSML. For PostNL, there are many event processing steps to be taken for the shipping and other events. And these are often small steps, such as filtering data, changing the structure of an event, branching the event into multiple steps. And to quickly develop these streaming apps, we use KSML, while actually none of the developers in our team are either experienced at all with Java or very experienced. So in the example I have here, I've attached an example on how to rekey or like change the value of a key of an event. So on the top, we can see that we've defined what streams we're using for input and output. And then the function we will run. So it takes the customer number from shipment parties customer number, and then it sets it as the key of the event. And then at the bottom in the pipelines section, you can see where the data is coming from, what it is doing in between. So it's going to that function that we were just looking at, and then where the data goes to. So yeah, we've seen that using KSML using KSML we can quickly develop these processors, if you will. It's easy also to look back at these processors and check exactly what every processor, what every step is doing. Next is observability. So yeah, given the context that we just looked at before, when business units start to decouple their applications using events, it's really easy to lose track of where what event went, where bottlenecks appeared. Having observability on these topics, therefore, is really important. And in Axual, there's a feature called Topic Browser, and we're using this feature a lot. It's also in the demo, but in short, teams really love to see if their event is received in Axual to a topic, on what environment, in what form, how many events were received. And we don't have to configure or deploy anything for this. Just by sending an event to a topic, you instantly get this business value, because we do also get questions from the business side about what happened to this barcode, where is it in the process, did you receive it at all, for example. And with this, it's really easy to check. All right, so for security, I would like to mention a few things. The first one is certificates. Through the self-service portal, stream owners can upload their MTLS certificates themselves. And this is nice, because then as an integration team or as a DevOps team, you don't need to have the certificates of the business unit. They can upload them themselves, which is much more secure. Then authorization. So here you see a screen of a user and the roles that they have and that they can have. So when I have the role topic author, I can create a topic. So that's based on a role-based authorization. And then next to the role-based access control in Axual, you also have attribute-based access control. So an example is when a user creates a topic, they are automatically the owner of the topic, and they can fully manage it together with actually the group that they are in. Lastly, the regulating topic access. So as a user, you can request access to a topic. So here we can see that there is an application called KSML example processor, and with the exclamation mark, it's trying to be a consumer, by the way. The exclamation mark means that the access was requested, but it's not yet granted. And at the bottom, you can see as a topic owner, you can see the access request, and you can approve or deny it. Okay, so I've mentioned a lot of things about Axual and how we use it, and I think it's time to see it in action by Mendolt.
By the way, hi, I'm Mendelt Leidenburg, part of Actual for 4 years now, and I'm a DevOps engineer. What you see here is the dashboard page of the actual platform. Here I can see all the topics that I have access to and applications that are owned by my team. We have nice overviews of topics that and applications that do exist. More details can be found in these tabs. And we have a very nice schema browser. So like Dee mentioned, schemas are very important to have the same structure of your data. Well, using the schema browser, it is very easy to see and compare different schemas that are currently used within the platform. So for the demo, I'm going to create a simple application. I'm going to do a make pretend postal service. There are some applications already running and some topics already present. What I want to do is to create a topic that contains unsorted shipping events, and that will be picked up by the mail sorter. So I'm going to go to topics and shrink this one a little. I'm going to create a new topic with the name mailboxes. Because, oh, no, sorry. The topic is going to be shipping events. Because it will contain shipping events. It will be owned by my team. Only my group can view it at this moment. And it's going to be a very simple topic using a string key and a schemaless JSON as a value. And it's going to be a deletion topic so that the data will be removed after several days. So I added this topic template. Now I can pick which environment, so which Kafka cluster should host this topic. For now, it's going to be in the test environment, and I can tell it to keep the data for 2 days and go for one partition. So by hitting save, now the topic is deployed on a live Kafka cluster. So well, that's nice, right? Next up would be to create some data. Well, I already made a Python application, but it needs to be represented within the actual platform as an application. So I'm going to create a application, and it's going to be mailboxes, because these mailboxes are going to generate shipping events. So again, I'm going to own it. And it's going to be a custom application of type Python, and everybody can see it. So I'm going to add the application, and I'm going to go for the same environment as where the topic is located. But of course, I need to authorize myself, right? So my application needs to get permission. So I'm going to use Sassel to create a bunch of credentials. And I need my application. I'm going to add my password and user to my application. And well, let's run it. And well, that's a demo effect, right? It worked just before.
Be producing to the topic.
Ah, yeah, of course. Sorry, yeah. So this shows the level of authorization that's needed. So my application is running, but I need to be allowed to produce on the topic. So thanks, Ewan. Yeah, I'm going to request topic access to the shipping events topic, and I'm going to request access. Right now, I am the owner of this whole installation, so I can approve it myself, but regularly this would be done by the data owners or topic owners themselves. So I'm going to approve it, and let's try that one again. Well, that's looking fine. No problems arising. I'm going to copy a UID for now, for later on. And well, let's see it, right? There is the shipping events topic. And I'm gonna hit search. So now we see there's a whole bunch of data coming in. When expanding the data within the browser, I can see address information, and very notably, there's a type. This is of type letter, and the mailboxes will get letters, postcards, and parcels. And every one of those items has a UUID. So I'm going to search for this UUID I picked up earlier. And here we go. There is the item, and oh, we see it as a postcard to the Netherlands. Okay, cool. This is nice, but this mail needs to be sorted, right? Because otherwise it will not go anywhere. So next up, I'm gonna activate the mail sorter application. So this one needs access as well. So I'm gonna give it, I'm gonna start a consumer request to the shipping events topic. Gonna request approval again, and I'm gonna approve it myself. Now we see everything is in place, and this application is not going to be a Python application. It's going to be KSML, and I'm going to show you now. So here I define the streams. We have the mail source, which is the shipping events topic. Then we have the parcels, the small mail, and the unknown items topics. Those are the downstream topics. And what my mail sorter application is going to do, it's going to check for the type of shipping item and see if it's a parcel that goes into the parcels topic. Letters and postcards go into small mail, and unknown items are for the rest. I'm going to save this and start it. It will take a few seconds to start up. In the past, I've created streams applications myself as a Java developer. It took me, let's say, a couple of days to get my first streams application running in Java. It was pretty tedious to develop, deploy, and get it running eventually. Right now with KSML, this application is already running, and my first try ever took me about 1 hour. So that's a major speed increase. So we see this application is now picking up shipping events, and it should sort the data. So let's follow the small mail. And remember, we picked up a UUID. This should be in this topic. So here we go. And here are the rest of the letters and postcards. So about half of them are postcards, the other half are letters. And downstream there is another one. There's the international sorter, which is very similar, and it will sort between international mail and Dutch mail. And it will just look for the country of the destination country. So let's go to the Dutch mail, check it out, and here we have the Dutch mail items. And if all goes well, we can see my UUID again. So the postcard to Patrick is going well. So that's the beauty of the platform. I hope you have seen enough, because I'm going to go over back to Guy. Thank you very much.
Nice. Thank you. Let me share. Okay, so I have a few closing notes. The results that we booked with the project so far is that we already went live with the business-to-business flows, and we are currently processing more than 100 million messages per day. Next, we are planning to continue expanding the business-to-business flows functionality, and we are adding the business consumer flow at the moment. Because we have the events flowing through our platform, it is easier to add webhooks, for example, as an integration pattern to the customers of PostNL. And now we can also leverage other technologies such as WebSockets.
All right, thank you, Mendolt and Guy. We now are over at the end of the presentation, and we would like to open the Q&A session. So if there are any questions, please use the Q&A or the chat in order to put some questions forward to the three of us. I see a couple of questions. First question is it possible to start with a small use case as a POC? Well, the small answer is, of course, yes. Use cases can typically be small. You can have test environments, test setups. You can run your own applications. You can have an actual platform run your applications. That is up to you to decide. So, well, I would say please get in touch and let us know what the POC intends to do and intends to prove. And of course, we can help in setting things up for you. All right, a second question. Are you able to determine the costs that are being saved with the new platform? And we think that is one for Guy, potentially. Are you able to share that, or are you more into the technical side of the implementation?
Yes, the latter. I do know some cost, but yeah, maybe it's a good question. What I can say is the cost saving is significant. The business case is the return on investment is within a few years, so that's typically really good, right? While also, of course, having more capabilities within your organization. Yeah, for specific numbers, I would have to double check with PostNL what is allowed to be shared. So maybe we can, or probably we can do that afterwards.
All right, thank you. There's a question: is it possible to integrate with Airbyte or Fivetran as a source destination?
Just did a quick Google, and it looks like both of them have Kafka integration possibilities. So that could be either a custom application or a connector, maybe. So yes.
Yeah, terrific. Thank you, Mendolt. And another question here: we are running Kafka Strimzi. Can I use the actual system on top? Also here, the definitive answer is yes. We use Kafka. We use Strimzi ourselves to deploy Apache Kafka on Kubernetes. And we're very much Strimzi focused. So definitely you can use the actual system on top of a running Strimzi in your own data centers or in your own cloud environments. All right, I think that's the list of questions that I have here, unless there are more coming in the next 2 seconds or so. Not then a lot of thank yous in the chat. Thank you very much for that. We hope, oh, there's one final question. Do you support custom connectors? Mendolt?
Yes, we do. Axual has made a few custom connectors, but you can write your own, of course.
Right, and upload them to the platform and use them.
Indeed.
All right, gentlemen, thank you very much for all the information shared. Thank you, everybody, for attending today's webinar. We hope it was useful for you, and love to see you sometime soon.